Hi, everybody. This is Dr. Shulman again. We're going through curriculum and we're talking about preparing for mistakes. I'm also going to add a piece about normalizing mistakes because I think it's really important. So I'm just going to jump right into it. Share my screen and strategies for misconceptions. I've got some videos here, some pieces here which we'll watch. But first, I just want to go over some basic mistakes that I've been seeing just by doing these problems once they come up. And the more problems that you see, the more mistakes you're going to realize and see where they happen and do your best to plan for them. So on the very first test, they gave us something like this: 3/5 minus 1/2. And they said that 3/5 minus 1/2, a common mistake is subtracting the numerators and the denominators. So they would be 2, a -2, and 5 minus 2 is, oh, sorry, a positive 2/3. This is not the right answer. This is if you were doing 3 minus 1 and 5 minus 2 to get 2/3. This isn't right. So you have to prepare for things like this. So if it's 3/5 minus 1/2, the first thing you have to do is get what's called a common denominator. So I'm going to multiply this by 2 and this by 5. That way I'll have 10 on the bottom. This is its least common multiple. Okay, that first time a 2 and a 5 look the same as when they're both 10. But if I do something to the bottom, I have to also do it to the top. So 3 times 2 is 6. And 1 times 5 is 5. So this answer should be 1/10 and not 2/3. That's a really common misconception you can help students find. Another one we saw was with exponents, and that's like when it was 3 to the 4th power. A common misconception is that students might just do 3 times 4. But we know it could be 3 times 3 times 3 times 3. 3 to the 4th power means this is the base, and my exponent is up 4, so I have to multiply these 4 together. 3 times 3 is 9. 3 times 3 is 9. So 3 to the 4th is not 12. It's actually 81. A third common mistake they said was the square root of 16 or the cube root of 27. So square roots, cube roots, people mess them up all the time, but you should always try to tell students that the symbols tell them what to do. If it's a square root, you have to build a square around this thing. This is the square that you're building. So I need to know what number times itself gives me 16. You see how I made a square of area 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what is each of the lines? It's a 4 by 4 square. So that is why the square root of 16 is 4. The common mistake is people would do 16 divided by 2 and got 8. That is wrong, okay? It's not divided by 2. The same thing, this is a cube. So it's not 27 divided by 3. This is not 9. It's 3 by 3 by 3. They're all 9 on the sides, so it's going to be 3. So these are just some basic common mistakes you're going to see. Your job is to plan for them. How can we plan for them? You can show students common mistakes, but you should always be very specific about what these mistakes are, where they come from, and how they look. Other mistakes I see all the time, it's 3x minus 2 equals 12. A lot of students might make 12 plus, I don't know, 2x. Like a basic common mistake that I usually see is that a student will add the 3x to both sides instead of subtracting it. That's something you might see when they're trying to move it over, which is wrong. You have to subtract it when you're moving across. Another mistake I see all the time is when it's a negative 3x minus 5 equals 12, okay, whatever it is. A lot of students just bring this to one piece and make it negative 3x minus 5 equals 12 and solve. However, this is wrong. It has to go to both. So it's a negative 3x plus 5 equals 12. Subtract by 5. You get negative 3x equals 7. Divide by negative 3 on both sides. X equals negative 7/3. Now, I'll do one more. But the more you do the math, you'll see where the problems are. You'll see where your students struggle, right? You're not really sure where the problems are until they start doing it. A geometry one that's real common is when they're trying to find the area, and this is 12 by 6. A lot of them don't realize that the area is 1/2 base times height, because if it was a rectangle, it would be 6 times 12, but this is half the size of the rectangle. So they still might do 12 times 6, but this is really half, so it's 12 times 3. So this one, your answer should be 36. Okay. Always make sure they're cutting this in half. I could do common problems all day long, but your job is to, like, whatever math you're doing is you got to anticipate for these things. You got to be able to see where the errors are and try to normalize them. And you can show them to students to see if they're making mistakes, but that's up to you how you want to address it. So I'll give you a couple ways to address it. A lot of times when students make mistakes, they get really frustrated, they get really upset, and then you have to figure out ways to still build their confidence, still make them kind of feel like they're learning no matter what. Why don't we do one more mistake? Here it is, a common exponent mistake that I see all the time. 3x to the squared, y to the third power, and we're raising this to the fourth, okay? A lot of times students do 3 times 4, which is 12, and then it's like boom, boom, and you got to add these. So this one, there's nothing here, so there's a 4 here. So it's not 12, that's 3 to the fourth power, which is 81. These are being raised, so you actually have to multiply them. So it's x 2 times 4, which is 8. Y is 3 times 4, which is 12. So 81x to the 8th, y to the 12th. So a lot of times, since these two are being multiplied, people will multiply this one as well, but it's still a raise. There's tons of rules like this that get confusing. The harder the math gets, the more complex it is. There's the more little spaces for mistakes. But the best thing to do is you recognize, like, when I make mistakes. Like when I did the pre-test, I showed you I made mistakes on, I think, 3 of them out of the 50 problems, right? I make mistakes too. Everybody makes mistakes, but mistakes are where we learn. And I'm going to keep bringing these up as we go through it, these common misconceptions that always happen. So let's watch the video and learn a couple things or two. So this is this girl from Stanford, and she's really great. So here we go.
I've been working on this problem for so long. I just can't get it right. Every time I try something, it just doesn't work. I keep on messing up. I should just give up.
We're going to learn to do this area because there's a ton of brain growth going on.
What do you mean? I've been failing at this problem.
Your brain has grown so much while working on this problem?
But I can't figure out. I've been making mistake after mistake. I can't do it.
Exactly. Every time you make a mistake, a synapse fires in your brain. Synapses are connections that your brain makes every time it grows and creates new pathways.
Really? Yeah. Struggle and mistakes and challenge are great for your brain. Your brain is like a muscle. The more you work it, the stronger it gets. And challenging problems are great workouts.
So I should make mistakes and struggle?
Yes, we learn a lot and have a lot of brain growth, especially when we're making mistakes and working on hard problems.
So don't give up. Keep going. Some problems go inside for years, and that's fine. What's important is how much you learn while you're trying to solve them. Keep taking risks. Keep making mistakes.
Yeah, and your mathematical thinking process is super important and awesome. So if you keep learning and making mistakes, that's what's important.
Wow, I had no
idea. I'm gonna keep working, and when I make a mistake, I'll know that my brain is growing.
Scientists now know that when you make a mistake, synapses fire in the brain. In fact, more synapses fire when you make a mistake than when you get work correct.
So you mean when you make a mistake, but then you work through it and get it right, your brain grows?
Well, working through a mistake's a good thing to do, but what they actually found was that people's brains grew and synapses fired, even when they didn't know they'd made a mistake. So the study showed that there were two possible synapse firings. The first came when people made a mistake, and the second came when they became aware they'd made a mistake.
But how can a synapse fire when you don't even know you've made a mistake?
That's a great question, and the best knowledge we have on this is your brain grows when you make a mistake, even if you're not aware of it. Because when you make a mistake, that's the time when your brain is struggling and challenged. And those are the very best times for brain growth.
Oh, that's so cool. Thanks.
All right, so that was a little video. I hope you found that interesting. I'm just gonna reload the page so it stops doing that. And this is something you should really share with your students, that making mistakes helps their brain grow, especially in these younger classrooms, to get them to start feeling like they're confident in the math. So this is also by Joe Bowler. This is a set of classroom norms that she has to set a positive in your classroom. And this is something you should really think about. So 7 favorite messages to give students, and there's some suggestions. Okay, so everyone can learn math at the highest levels. The mistakes are valuable. Okay, so students are making mistakes, be like, this is showing us processes and actually helps us to understand the underlying pieces. Questions are important. Math is about creativity and making sense. Math is about connections and communicating. Math class is about learning, not performing. And depth is more important than speed. So these are really good pieces to really keep in mind when you're trying to set up your classroom, things to think about. So this is a growth mindset for mathematics with some videos along with it. And here's the piece I want to show you. The mistakes are valuable. So that you love mistakes and that they will be valued at all times. Tell them it's good to make mistakes, as we know that when people make mistakes, their brains are growing. The single message can be incredibly liberating for students. And hear about some suggestions. So this is actually how you can do it in your classroom, which I think is great. So with mistakes, to present their mistakes on the board so everyone can learn from them. If one student makes a conceptual mistake, there are probably many others making the same one. So be like, this is the hardest part of the problem. Really emphasize like how useful it is that we're seeing this mistake and we can all address it together. When students get something wrong, instead of being discouraging, say your brain just grew. So like change the mindset. Like if you make a mistake, be like, this is something that's useful for you. Ask students to read positive brain messages and choose their favorites for the year. E.g., easy is a waste of time. Working hard grows your brain. It's important to make mistakes. Ask them to draw brains with the message on the walls. Here's some cute brains being drawn. This is the one I've used. I've used this crumpled paper before, and I'll give you the activity I use for it. And students love this one. I've used it in higher level math as well. So ask students to crumple a piece of paper and throw it at the board when they feel they've written a mistake. Then get them to receive the paper and color in all the lines. And the lines represent all the synapse firing while they were making the mistake. And ask them to keep the piece of paper in their folders to remind them of this. So I've definitely done the crumpled paper. I'll show you the ones that I've used. So here's 2 really hard problems. A lot of times I give my students challenging problems just to see how they'll do with it. So this is one that I made. And there was a video that went along with it that my students like. So here it is. I'll download this as a PDF so I can draw on it. And I'm not going to give you the answer to this in case you want to try it yourself. Crumble it and throw it against the wall. So I showed them a clip from the Office Space. The Office Space movie. It's way before your time, but it's basically just like a movie about this guy, and then he destroys his cubicle. So a state-of-the-art office technology wants to use a circular workroom to maximize workspace for their top 4 employees. They want to divide the room into 4 equal sections using only 3 privacy curtains. Each curtain is the same length. How might this be done? How can we find the exact length of each privacy curtain if the 4 workspace measures 108 feet squares, the typical size of a cubicle? So a lot of students will do this. 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 A lot of students will and be like, I have 4 equal spaces, but these are just 2 curtains. We need 3 curtains of the same length. So that's off. Another common thing students will do is they'll do this. 3 equal spaces. I mean, 3 equal privacy curtains. However, the curtains are not the same length. Another thing that I've seen that's a mistake is that students just do this and they try to like 1, 2, 1, 2, 3, 4. They try to make this as equal as possible with these lines, but it's really hard to do. So this isn't either. So none of those methods do it. You can try it yourself. If you get really frustrated and you want to know the answer, just shoot me an email. I'll show you the picture. I actually had the picture first, and then I wrote the math problem. I like created this cool image, and I was like, oh, how do I make this into a math problem? That's how I did it. So some students have done this, make like a Z. That's not right either. So this one's longer than the other two. So you can give it a shot, try your best if you want to try it. But lots of papers were crumpled and thrown at the board, and it was just a good learning activity. Here's another really hard one for students. This is based off of Patterson, and I have a lot of Patterson stuff for geometry. So it starts really easy, and notice it starts and gets more and more complicated as it goes, like all good math examples. So we got our friend Scruffy the dog. I gotta download it. Our good friend Scruffy the dog. And I'll draw. And 6-foot leash. So what is the area for this one? So he can go around in a circle. There's my good friend Scruffy. So the radius is 6. Area of a circle is pi r squared. So this is 6 times pi. So it's 36 pi. And it's feet. So it's 36 pi feet squared. That's the first one. But now we've got Buzz the cow. And Buzz can only go not all the way around. You see? So Buzz can go how much of the circle? So Buzz can only go 1/4 because that matches. So this is 1/4 times pi r squared. And the radius here is 12. So 12 squared is 144 pi. And I got to multiply this by 1/4. So that's over 1. 1 times 144 is 144. 4 times 1 is just 4. So we need 144 divided by 4. So 144 divided by 4. 4 goes in 3 times. 4 8 times. So this is 38 feet squared. I'm just going to make sure I did that right. Nope, I did it wrong. So I did just this piece, the 1/4, but he actually goes around how much? 3/4 of the circle. See, it's 3/4 of the whole way around. I thought, and how could I know that? So if the whole thing is 144 and I'm doing 3/4 of it, it's got to be way more than 38. So it should be 3/4 times this. But since I already have the answer of 38, I can just multiply 1, 2, 3. So I can just multiply this by 3 and I'll get the right answer. So that's a 4. Carry the 2, 3 times 3. So it's 114 feet squared pi. We still have 114 pi feet squared. And look, I just made a mistake. You know what that did? I used estimation to realize I made the mistake. If this whole circle is 144, there's no way 3/4 of that circle is going to be just 38. That's how I know I made a mistake. You want to see it the correct way done from the beginning? I will do it the correct way from the beginning. But this is how useful mistakes are. This is how useful they are when you're working with these problems. As long as you're making the mistakes, the problem will get way easier for you and your students. So it's 3/4 times pi r squared. So we know it's going to be 3/4 times the radius, which is 12 squared. And I usually put the pi at the end. So 12 squared, so it's 3 times 144 divided by 4 equals pi. And then 3 times 144 44 times 3 is 12, carry the 1. 12, so 13, carry the 1. 3, 432. So I have 432 divided by 4. Big number goes in the house. 4 goes into 4 once. I might have made a mistake because I'm running out of space. So I'll just do it over here. 144 times 3 is 432. 432 divided by 4 is 108. I guess I messed it up when I divided it. So it is not 114, it is 108. 108 pi b squared is the right answer. So let's see if that was correct. Let's go back and let's do 38 times 3. Yeah, so you can't go the other way. You have to do it correctly. If I just multiply this by 3, it's not giving me the right answer. So that's okay. It should be 108 feet squared. So let's make sure that's true. How can we make sure it's right? So it's 108. And then I need the whole thing's 144, right? So 144 minus 108 is 36. Now, when I did this one before, did I mess it up? So this one probably should be 36. So let's see. Let's see if I go the other way. So let's do 1/4. So this one should have been 36 from the start. So I messed it up twice, which is okay, right? We all make mistakes. That's the whole point of this one. So 36. Let's see if I will get 36. So let's do 12 times 12 is 144. Then I just have to multiply this by 0.25 because that's 1/4. And 36 is the answer. Cool. So it works either way. The answer is 108, which is totally fine. All right. So now, even though that one was tough, it's gonna get even tougher, right? So the whole point of this is to increase in difficulty as we go through it. So we got 108. Pi feet squared. All right, so now here we've got our good friend Billy the goat. And here we have a circle here. And I can go halfway around the circle. I can go a quarter way around the circle. So that's 3/4. But then my 8 feet, this is 5, it's shorter. The last piece gets kind of cut on the end. And this last quarter of the circle is not 8 feet. 8 minus 5, so this one's 3. So it's 3/4 pi r squared plus 1/4 pi r squared. I'll do a different color for the little one. So notice that this is 3/4 of a circle and this is 1/4 of a circle. So the first one's 8 feet all the way around, then it gets kind of caught up here. So here we go. 3/4 times 8 squared pi plus 1/4 times 3 squared pi. So 3 times 64 divided by 4 pi. 64 divided by 4 is 8. So the first group is 24 pi. 3 squared is 9. 9/4. Well, 9/4 isn't fun, right? So I can take this 9/4 and divide it. 9's in the house, 4 is outside, so that's 2. 2 and 1/4. 24 pi plus 2 and 1/4 pi feet squared. So what is this? 26 and 1/4 or 26.25 pi feet squared. Either way you want to write it, we got the right answer. So yeah, that's harder because you got 3/4 and 1/4. And then even tougher, we've got our friend Pauline, the porcupine, and even more challenging. So You can try this one if yourself, if you want answers to it, you can let me know, but I think this is just a really good way to like give students tough problems to help them make some mistakes. Show them that it's really helpful for them as they go through it. I hope that was helpful. Feel free to reach out if you've got more questions.